Hello students, and welcome to the first lesson of this unit where we will study the numbers of our world. Today we're going to focus on the first of two essential questions. We're going to focus on what are the major types of numbers in our world. And by the end of this lesson, you should be able to tell what the 7 types of numbers are and what are some examples of those types of numbers. Our second essential question we will touch upon at the beginning of this lesson, but we will focus more on later, and that is, what situations can numbers represent? So I want you to think about it. What are numbers? If I told you to visualize a number, you will probably think of one of two things: the symbol that a number is, how you would write it, or a situation that it might represent. So let's think about this situation. Tex is 5 inches taller than Sally. The number in this sentence is the number 5 right here. What does 5 really mean? Well, the number 5 is the amount of space that's in between Sally and Tex's heights. Here's another situation coming in on the new year. 2014. What does that really mean? It really means the amount of time in years since BC began. 2014 years. It's an amount. So if we are to define what a number is, we will define a number as a symbol used to describe an amount. So let's take the number 5, for instance. The pattern that I just wrote is a symbol. It is a written picture, and that picture represents an amount. It represents this many: 1, 2, 3, 4, 5. So a number is both the symbol and the amount that it represents. So let's talk about what types of numbers exist. Let's get some background first of all. When you were in kindergarten, you first started to study numbers, and you might have studied earlier with your parents or at preschool, but either way, wherever you started your studies, you started with these numbers: 1, 2, 3, 4, and so on. After you learned these numbers, someone told you there is a number 0 that represents having nothing. Afterwards, you learn that there are numbers between 1 and 2, such as 1.5 or 1.5. Somewhere around 5th or 6th grade, you learn that numbers can be negative. -10, like I owe the cafeteria $10, -10. And finally, you learned about some special numbers such as pi, which is a geometry number that represents 3.141 and so on. It is a non-terminating number. It goes on and on forever. We usually round it to be 3.14. It's really a non-terminating number. All of those numbers that we just talked about fit within 7 types of numbers: natural numbers, whole numbers, integers, irrational numbers, rational numbers, prime numbers, and composite numbers. There are 2 pairs that I would like to point out to you, and that is the pair rational and irrational numbers. Every number is one of these. You can only be one of those 2. And prime and composite numbers are opposites of each other as well, and you can only be one of these 2. So if you're a prime number, you cannot be a composite number, and vice versa. Let's start by talking about natural numbers. Natural numbers are the numbers that occur most naturally in the real world. They are also called counting numbers. They start at 1 and count up by ones, and there are infinitely many of them. An example of a natural number that you may have encountered in kindergarten would be the number 100. Perhaps on the 100th day of school, your teacher told you to bring in 100 of something. You might have brought in 100 noodles, 100 pennies, but you took something in the real world and was able to represent the number 100. That makes it a natural number. When you take the set of natural numbers and add 0 to it, you get the set of whole numbers. Whole numbers are the counting numbers from 0 to infinity. 0, 1, 2, 3, and so on. Integers are similar. They include 0 to infinity, but they also go in the negative direction as well. -1, -2, -3, and so on. They are all the numbers that count up and down from 0 by ones. Here's a depiction on a number line. Notice it starts at 0. It's the numbers from 0. They go up by ones to infinity, and they go down by ones to infinity. Notice none of the numbers have decimals or fractions. Irrational numbers, remember, they're the opposite of rational numbers, are numbers whose decimal does not repeat and does not terminate. Think about what it means to repeat. If you repeat, you do the same thing over and over. For instance, if a decimal does repeat, it would be like 0.555, and so on. Or 0.1212, and so on, repeating the 1, 2. These are examples of repeating decimals. Irrational numbers do not repeat, so they do not repeat. They also do not terminate, which means they do not stop. They go on forever without repeating. An example would be the square root of 3. I know we haven't studied square roots much, but if we use our calculator and we type the square root of 3, we see that it's very long. It does not stop. It takes up the whole screen. It would go further if the screen was larger. And it doesn't repeat. You do not see any repeating pattern in here. Yes, there are 2 8s in a row, but that does not continue. The square root of 3 is an example of an irrational number. Remember, there are 2 characteristics. They do not terminate. They're non-terminating. They do not stop. And they are non-repeating. They do not repeat. Rational numbers are the opposite. Rational numbers do repeat or they terminate. So they have at least one of 2 characteristics. They either terminate, which means they stop, or they have a repeating decimal. So what's an example of a terminating decimal? Take the number 15. Does it stop? Yes, I stopped. Whenever I stopped writing the 5, that means that I stopped the number. It doesn't have anything afterwards. Now, you could also say that 15 is a repeating decimal because it's 15.000 and so on, repeating the 0. So the whole number depends on how you look at it. It can be both a terminating or a repeating decimal. 3.25 is a terminating decimal. It stops. It doesn't keep going on and on. A repeating decimal would be like 5.333, and the 3 is repeating. You often see a bar over the top to show that that number repeats. Prime numbers are a number whose only factors are 1 in itself. A prime number can only divide evenly by 1 and itself. So for instance, take the number 11. The only numbers that 11 can divide by are 1, which will give you 11, or 11, which will give you 1. Any other number that you try to divide by will result in a decimal, such as 11 divided by 2 is 5.5. That means that 11 does not divide evenly. by any number other than 1 and itself. It has only 2 factors. The opposite of a prime number is a composite number. These are numbers that have more factors than just 1 in themselves. They can be divided by at least one other number. An example would be the number 15. Yes, 15 can divide by 1 to get 15. And yes, 15 can divide by 15 to get 1, but it has other factors, such as 3, which would result in 5, or 5, which would result in 3. It has factors other than 1 in itself. So here's a question for thought. We've talked about 7 different types of numbers. Can a number be in more than one category? And the answer is yes. Take the number 12. 12 is a natural number. You could take rocks and show me 12. You can represent it naturally. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Likewise, if you started counting at 0 up by 1s, which is the definition of a whole number, you could get to the number 12. 12 is also an integer because I could start at 0 and count up by 1s to reach it. Is 12, remember you can only be one of these two, rational or irrational? Let's start with rational. Rational means it stops or repeats. Does 12 stop or repeat? Yes, it stops. It also can be repeating. If you think about it, it repeats the 0 after the decimal. So this is a rational number. Now, is it prime or composite? Remember, it can only be one of these two. Can 12 divide by something other than 1 in itself? Yeah, it could divide by 2, which would give us 6. It could divide by 3, which would give us 4. So we have proven it's a composite number. It can divide by numbers other than 1 in itself. So 12 actually fits within 5 of the 7 categories. 12 is a natural number, a whole number, an integer, a rational number, and a composite number. Let's look at another example. Let's look at the number, the square root of 2. Now, most of you may not know what the exact value of that is, but if we take our calculator, we can see what that value is. So 2 square rooted, we get 1.4142135, and so on. Is this a number that we could represent very easily with natural numbers? No, because it's between 1 and 2. Since it's between 1 and 2, is it a whole number? No. If it's not a whole number, is it an integer? No. Now we need to decide, is it rational or irrational? So does it terminate? No, it does not terminate. So it could be either of these. Does it repeat though? Are there any digits here that repeat and make a pattern? No. This is an irrational number. Okay. Only whole numbers are classified as prime or composite. So this number, the square root of 2, is merely called an irrational number. So, to summarize, you need to remember there are 7 major types of numbers in our world, and any one number can be more than one type. Have a great evening, and we will talk more about this and practice more tomorrow. Have a great night, students. Bye.